Chapter 1.4.1.2 Init Containers. Init containers are specialized containers that run before app containers in a pod. They can contain utilities or setup scripts not present in an app image. Init containers are specified in the pod specification alongside the containers array, describing app containers. In Kubernetes, a sidecar container is a container that starts before the main application container and continues to run. This document focuses on init containers, which run to completion during pod initialization. In summary, init containers are essential for preparing the environment for app containers to run smoothly. Understanding init containers. A pod in Kubernetes can have multiple containers running apps within it, as well as one or more init containers that run before the app containers start. Init containers must run to completion, and each init container must complete successfully before the next one starts. If an init container fails, the kubelet will restart it until it succeeds. But if the pod has a restart policy of never and an init container fails during startup, the pod is treated as failed. To specify an init container for a pod, the init containers field is added to the pod specification as an array of container items. The status of init containers is available in .status.initContainerStatuses. Init containers support features like resource limits, volumes, and security settings, but resource requests and limits are handled differently. They do not support lifecycle, liveness probe, readiness probe, or startup probe fields. Init containers run and complete tasks before the main application container starts, unlike sidecar containers which run continuously alongside the main containers. Init containers share resources with the main application containers, but do not interact directly with them. They must complete successfully before the main container starts, and do not support certain probes. Using init containers. Init containers in Kubernetes have separate images from app containers and offer several advantages for startup-related code. They can contain utilities or custom code for setup that are not present in an app image, such as tools like sed, awk, Python, or dig. Init containers can run with a different view of the file system than app containers in the same pod, allowing them access to secrets that app containers cannot access. Furthermore, init containers run to completion before any app containers start, offering a mechanism to block or delay app container startup until preconditions are met. This can be used to securely run utilities or custom code that would otherwise compromise the security of the app container image. Examples of how to use init containers include waiting for a service to be created, registering a pod with a remote server, waiting for a set time before starting the app container, cloning a Git repository, and generating a configuration file dynamically. A simple pod example with two init containers that wait for specific services is provided, demonstrating how to run the pod and check its status. Overall, init containers provide flexibility, security, and control in the deployment process in Kubernetes, allowing for a more efficient and secure setup of pods and app containers. Detailed behavior. The kubelet delays running init containers during pod startup until networking and storage are ready. Init containers are executed in the order they appear in the pod spec and must exit successfully before the next container starts. If an init container fails, it is retried based on the pod restart policy, with the option to use on failure if set to always. The pod cannot be ready until all init containers have succeeded and their ports are not aggregated under a service. A pod in the pending state should have initialize set to false, and if the pod restarts, all init containers must execute again. Changes to the init container spec are limited to the image field, with alterations not triggering pod restarts or recreation. Code in init containers should be idempotent, particularly when writing to empty dar volumes. Init containers have the same fields as app containers, but readiness probe is prohibited due to an inability to define readiness separate from completion. To prevent init containers from failing indefinitely, active deadline seconds can be used, though recommended only for applications deployed as jobs. Resource sharing within containers is determined by the highest resource request or limit among init containers. Scheduling is based on effective requests and limits, with QoS tiers and quotas applied accordingly. Pod restarts may occur if the pod infrastructure container is restarted, or all containers in a pod are terminated under certain conditions. Overall, init containers play a crucial role in setting up a pod, with specific considerations for their execution, resource usage, and potential restart scenarios. By understanding these guidelines, users can effectively manage and troubleshoot pod initialization processes in Kubernetes environments.